Alright, welcome back to another LeetCode 15-minute challenge video. Today we're going to be doing a single element and sorted array problem. It's LeetCode number 540, and we're going to see if I can figure this out in 15 minutes. So let me go ahead and set a timer or stopwatch thing. Okay, 15 minutes starting now. Let's go. Okay, so we are given a sorted array consisting of only integers where every element appears exactly twice, except for one element which appears exactly once. Find the single element that appears only once. Okay, so that tells me that the array must be of odd length, because if every element appears twice and there's a single element that only appears once, that means the length of the array is an odd length. Okay, and oh shoot. Follow up, your solution should run in O of log n time. Okay, so if we're searching for something and it needs to be in O of log n, I think binary search is probably what it wants us to do. This is a follow up though. Should we just skip to, let's try the follow up. Let's try doing it right in binary. Okay, so if we're going to do it in binary search, we need a low, and our low is going to start at 0, and we need a high. And our high is going to be equal to the length of our array minus 1. Yeah, that's about right. Okay, so now we just loop. Alright, so while low is less than high, yeah, we want to, how should we check this? So let's see, if we have an array, these are these are our locations, and these are our values. So we do 1, 1, 2, 2, and then 3. So the 1s appear twice, the 2s appear twice, and the 3 appears once. These are the index values. How do we do binary search on this? So we're gonna start at, oh, we need a mid. So our mid is going to be equal to our low plus our high divided by 2. Okay, so we're going to be in the middle right here. This is our index. We can, ooh, okay. So what you could do is, this is your value in the middle. And you can say, okay, if the value, okay, first, actually, okay, if it's an even in, oh, okay, yes, there we go. I think I got it. So if it's an even index, that means that everything on the left is potentially fine, right? And on the right, so if it's an even index, that means this 2, its second 2, technically should be on the right side of it, right? Because you can't have an even index and, like, for example, this 2 could not be right here, because then, yeah, that makes sense in my head. It's a 15-minute challenge. I'm not trying to explain it that well. Okay, so yes, so we need to check its if it's an even index or if it's an odd index. So we're gonna say if the middle of the array is an even number, then we're gonna do something. If it's not even, then it must be odd. So then what are we gonna do? We're gonna say, so we might need to check, okay, if the value to the right is equal to it. So if nums at mid is equal to nums nums at mid plus 1. So if that's true, so if this 2 is equal to this 2, that means that the single element that we're looking for has to be on the right side. Yeah, that means it has to be on the right side. Okay, so this means our value must be on the right half of the array. Okay, so then if it's on the right half, then all we're going to do is we're going to say our low is going to be equal to our mid now. Yeah. All right, and if this isn't true, this means our value is or must be on the left half of the array. If this is true, then we're going to set our high equal to our mid. Oh, we got it. We got it. All right. Oh, nope, don't open stuff. Okay. So if it's not an even number, though, that means it must be odd. So then we'll do the same thing. We will check if nums at mid is equal to nums at mid plus 1. And if this is true, we're going to set our low equal to mid minus 1. And we're going to set our high equal to mid. No, this is going to be mid plus 1. This is going to be minus 1, right? So if it's an odd number, so if we're at an odd index, so for example, we end up right here. Okay, so we start off with this list. This is our middle, right here, these two twos. If it's an even number, okay, compare these values. So we're going to compare 2 and 2. This is true. That means our new low is set equal to our mid. So this is our low. So we can ignore this half of the array. This is our new array that we're looking at, essentially. So this is our low, this is our high, and this is our new mid. Okay, so this is our mid. This is an odd index because it's at location 3. So now we're going to say if this 2 and this 3 are equal to each other, then, or sorry, if they're not equal to each other, then our high is going to be equal to our mid minus 1. No, that doesn't make sense. So if it's odd, so we're right here, this is our new mid, this is our mid, and if these two equal each other, we're at an odd index. So if we they're equal to each other, then our low is going to become our mid plus 1, but that's not true. So that means our high is going to be equal to our mid, where our mid is minus 1. So this is our, oh, and then we break out of our loop. Yeah, because then low is less than high. And then, well, let's see, our high would be this one, and our low, what would our low be? Shoot, I got lost. So we start here, compare these two values. We compare 2 and 2. That is true. So that means our low is going to be equal to our mid. So this is our new low. Our low is a 2. Or should I say this 2 actually? Then we want to check. So this is the low. This is the high. This is the new mid. Mid is 3. And mid is an odd number. So then we're going to say, okay, does num at mid, which is a 2, equal to num at mid plus 1, which is a 3? No, it doesn't. So then we're going to change our high to be equal to mid minus 1. No, that shouldn't be the case. Our high, what's our time? 9 minutes. I thought we could figure it out faster. What? This is our high. This is a mid. This is a low. High equals mid, which is 3 minus 1, 2. So our high is 2. We should break out of our loop. High is 2. Mid is this. Low is that. I think we're going to return our low. Maybe I have these flipped. Let's just run it. We're going to return our nums at low. I think I have some signs flipped. Yeah, we do. Okay. Maybe this is -1. This is, oh wait, no, this should be -1. Yeah, so if we're right here now, this is our mid. We want to compare, okay, is this value, yes, this makes sense. Okay, so we want to check, okay, are these two values the same? Because if it's an odd number, that means technically its pair should be on its left, because like we said at the beginning, if it's an even number, its pair has to be on the right of it. Okay, so if that's true, then our low is going to be equal to mid plus 1. So our low, which is originally 2, is going to be equal to mid plus 1. Low is now greater than high. Oh no, they're equal each. Two. Oops. So low would be 4, high would be 4. And then yeah, we break. Oh yeah, that, I think this works. I think this is gonna work. Oh wow. 10 minutes. Wait, what's our time? Our official time? Oh, I still got 4 minutes left. I don't know if you can. 4 minutes left. All right, let's submit it. Let's see what our. That's how you do it. That is how you do this problem. Single element and sorted array. Nice. Cool. All right. See you next time.